Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, students of Senior 2 Chemistry class. You are welcome for today's lesson. Today we are starting Unit 2, which is Trends in Properties of Elements in the Periodic Table, right? Trends in Properties of Elements in the Periodic Table. So, from there we are starting with Lesson 1, which is Classification of Elements and Physical Properties of Metals. So, everybody pick your pen, pick your book, and we start with the lesson. I think you're all ready to start off with the lesson. Are you ready? Good. So what is the objective of the lesson today? Today's objective, we are going, by the end of this lesson, everybody will be able to describe the classification of elements and the physical properties of metals. All right? To describe the classification of elements and the physical properties of metals. So you need to be very attentive such that at the end of this lesson, everybody will have achieved this objective. So we can start off with the lesson. So that is the periodic table that we are going to look at. Look on the slide there. Everybody try to look on the slide. This is the periodic table that we are going to look at. So the classification of elements into that periodic table. So as you see from the slide, we have very many, around 118 elements there. But at our level here in Senior 2, we normally put emphasis as the only 20 elements of the periodic table. All right? So as I've said, we have around 118 plus elements in the periodic table. But in all level, that is Senior 1, 2, and 3, we mainly put emphasis on the first 20 elements of the periodic table. Right? That's why you see those that are shaded in yellow, these ones which are shaded in yellow. Right? Can you see these ones shaded in yellow? Everybody? You can look at these which are shaded in yellow. Right? These are some of the periodic table we are going to look at. To summarize this, the periodic table that we need to focus at when we are still in O level, I'm going to design a simple sketch of the periodic table or of the elements that we normally put emphasis on when we are still in O level. And those are the ones that normally we are going to discuss most under this lesson. So these are some of the elements that we have. Normally, you remember in Senior 1, they told you we have around 8 groups and 4 periods. All right? So we have, we can try to design it. This is the periodic table that we normally, the sketch of the periodic table. We need to draw 8 groups, 1, 2, 3, 4, 5, 6, 7, and 8. And we need to put 4 periods. 1, 2, 3, and 4. All right? Just a sketch of the first 20 elements of the periodic table. All right? So this is P1. Period 1, period 3, period 2, period 3, and period 4. This is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and lastly, group 8. All right? So these are the 8 groups that normally put emphasis on, and the 4 periods. So here we have hydrogen, here we have helium, this is iridium, beryllium, boron, So these are the ones that normally we put emphasis on. The first 20 elements of the periodic table that we focus at when we are still in O level. But it doesn't mean that we don't look at the rest of those. Those ones also, among these, also may come in. So whenever you see we are talking about copper, we are talking about zinc, any other element may come in, all right? But mainly, we put emphasis on the first 20 elements of the periodic table. Right? So we're going to see how to classify them, how to classify these elements. So normally, these elements are classified in 3 ways, as we're going to see down here. So we're saying there are around 118 chemical elements known at present. These elements are classified in 3 ways. Those are the metals classification. We have the metals, right? We have the metalloids. The metalloids, in other words, you call them the same metals. We have also the nanometals. Right? This is how we classify these elements here on the periodic table. Even on the other periodic table of these 18 elements, we put them in 3 categories or in 3 classes. Where do we find the metals? In the periodic table. Where do we find the metalloids on the periodic table? And where do we find the nanometals? So when we use this simple periodic table for our level here, the group 1 elements, group 2 elements, and group 3 elements, these ones are these ones here, group 1, group 2, group 3. Maybe I can use a separate color. We call them metals. So these are metals. All right? These are metals. Write M here. So we have group 4 elements. There are only 2 for this case, but on the other general periodic table, there are more than 2. So you can see here. They are here. Right? Now, metalloids. The metalloids are very many. So these ones here in the middle, for our case here, these ones are the metalloids. The metalloids. All right? The metalloids. Group 4 elements, in other words. So the rest here, we call them the nanometals. All right? The nanometals. Group 5, group 6, group 8. Those are nanometals. All right? So that's how we classify them. So the first 3, for this case here, there are metals. The group 4 elements are nanometals. I mean, are same metals or metalloids. Then group 5 to the rest, we call them the nanometals. All right? That's how we classify them. And they have different characteristics or different properties. So those in the same category or class have the same properties, and those in the same class have the same categories. So we are saying that the metals appear at the left-hand side and the middle of the periodic table. The metals appear at the left-hand side. That's why they're here. This is the left-hand side. Right? They appear on the left-hand side. So the nanometals appear on the right-hand side. This is the right-hand side. then the metalloids appear in the middle here of the periodic table. All right? So, in the periodic table, there is a regular variation in properties of elements in groups and periods. Those in the groups, they may be in the same class, but in the different group or in the different period. So those that are in the same, there is a difference when you talk of the period. And this is what I'm talking about. You say lithium, beryllium, and boron, they are in the same class. They're all metals, but also in the same period. But they don't have the same properties. Some difference in or some variation in their properties. Lithium, beryllium, boron, in the same class, they're all metals, same period, but they have some variation in their properties. That's what we're going to see. So there are also some in the same group. So when we are moving downwards, we call them the groups. When we move horizontally, we call them the periods. So those in the same group also have got also some variations. You get me? So we're going to see that difference and why. So let's start by looking at the differences in elements that are in the same period. So when you look on the slide there, we have picked the third period. That's P3, which is sodium. Sodium, you can see on the slide, have sodium, magnesium, aluminum, etc. They are in the same period. But we have said they have differences or variations in their properties. We're going to see why and what brings that. That's what we call the metallic character. So when we start by looking at metals, variation in metals, these are metals, all right? The variation of metals. So when you move across a period, all right? When you move across a period, for the case of metals, that's what we have started with. For the case of metals, take an example of group 3 for metals, that is sodium, magnesium, aluminum, for example. So when you move across a period, the metallic character decreases. We're talking about the metallic character. The metallic character decreases when you move across a period. It decreases. What does it mean? It means that sodium is more metallic than magnesium, and magnesium is more metallic than aluminum. So when you move across a period, the metallic character decreases. What brings that? What brings that, students? Why do you think, or why is it that we're saying that when you move across a period for metals, the metallic character decreases and the non-metallic character increases? Who can try on that? So the reason being that no matter when you are talking about that for metals, we look at the capacity of an element to donate electron. To donate electron. To give an electron. Those that can easily, take an example of those elements in period 3, as we have said, for metals. Period 3 for metals. For metals, we have got sodium, we have got magnesium, we have got aluminum. So when we do what we call electronic configuration, normally sodium have got atomic number of 11. Its electronic configuration is 2, 8, and 1. All right? Magnesium have got 12. Electronic configuration is 2, 8, and 2. And the aluminum have got 13. Electronic configuration, which is 2, 8, and 3. All right? So they have the same number of shells. 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. They all have the same number of shells. No difference in the number of shells. Because obviously in senior 1 we learned that the number of shells for an element, that is its period. So whenever we say they are in the same period, obviously the number of shells must be the same. Since they all belong to period 3, they must possess 3 shells. So that one we have no doubt there. But what brings the difference in sodium being more metallic than magnesium, and magnesium being more metallic than aluminium? That's what we're going to see. So I've said that when we look at that metallic character, we base on the capacity of an element to donate electron. The capacity of an element to donate electron. For example, here, when we look at the outermost shell, normally it's the outermost shell that loses electron or that is involved in the reaction. So for this case, when we look at the outermost shell for all of these 3 elements, you see sodium has got only 1 electron. So the one that has got less number of electrons, it is very easy for it to donate that electron, right? It's very easy for it to donate that electron. So being a fact that sodium has got the less number of electrons, it is very easy for sodium to lose 1 than magnesium losing 2, and very easy for magnesium to lose 2 than aluminium losing 3. So that's why we say, as you move across a period, the metallic character decreases, since the capacity to lose electron also goes on reducing. I think that is very clear for everybody. Good. So we go for nanometers. Or else we can finish looking at down a group now, 4 meters. Down a group. We have been talking about across a period. Now down a group. Down a group 4 meters, down a group 4 meters, the metallic character increases. It is the opposite of the other. The metallic character increases. Take an example of elements in the same group, group 2, for example. All right? Group 2 elements, we have beryllium here. We have magnesium. Also have calcium. All right? So beryllium has got atomic number 4. Atomic number 4, then electronic configuration 2,2. Magnesium has got atomic number, as I said earlier, 12. Electronic configuration 2, 8, and 2. Then calcium has got 20. Then electronic configuration 20. That is 2, 8, 8, and 2 again. You see, as you move down a group, the number of shells go on increasing. We have 2 shells here, have 3 shells, and 4 shells. So the number of shells increases. So as the number of shells increases, there is an increase in what we call atomic radius. What is atomic radius? Atomic radius, that is the distance from the nucleus to the outermost shell. All right? So as the number of shells increases, atomic radius increases, the attraction force from the nucleus reduces. What does it mean? It means that as the attraction force decreases, the capacity to lose electron also increases. That's why, since this one has got a large atomic radius, the attraction force is very less, so it is very easy for it to lose electron. So the metallic character increases. To react is very easy for it. So that's why we say the metallic character for metals, as we move down a group, increases. You get me? That is the example I've given there. In the slide, we have been trying to explain what we said. This is what we are talking about. For nanometers, in groups, I've tried to say, in general, we can say that the greatest metallic character is found in element in the right-hand side, in the left-hand side, and the metallic character is found on the right-hand side. Why? because we have said that the metallic character decreases from sodium to magnesium to aluminum, and silicon is a metalloid. I talked about that. The non-metallic character increases from phosphorus to chlorine. So in brief, get know that as you move across a period, metallic character decreases. Why? Because there is an increase in the number of shells in the outermost shell, giving it the element hard, or being it hard for it to lose that element since it is greater. So the less the number of electrons in the outermost shell, for those with the same number of shells, is very easy. It's very difficult than the one having less number of electrons. So for down a group, it's very difficult to lose electron when the number of shells are less, and very easy when the number of shells are many. All right? That's for metals, sorry. So for nanometals then, nanometals. So for nanometals, across a period, so let's take an example as I've given there on the slide. For nanometers, when you move down a group for nanometers, take an example of those ones there. From this is for metals, for nanometers, group 17, that is this group here. Take an example of fluorine. That's down a group. Fluorine, chlorine, and the bromine and whatever in the largest periodic table. Let's take fluorine, which is, when we talk of fluorine, this is like, it has 9. Then chlorine has got 17. All right? So when we do electronic configuration here, we shall get 2, 7, 2, 8. This is 10, 7. All right? So still we look at the number of shells are different. That's down a group. So because we're saying down a group, it is the non-metallic character decreases. The non-metallic character decreases. Why? Since it has less number of shells, the attraction force is very high. So it is very easy for fluorine to attract. That's because the nanometals, they react by gaining electrons. So it is very easy for fluorine to gain electron than this one, which has got attraction force, which is less. So the ones with less number of shells have attraction force, which is very high, and very easy for it to gain electron. That's why we say fluorine is more non-metallic than chlorine. So down a group, non-metallic character decreases. All right? So the opposite happens for across a period. So when you move across a period, for nanometers, the non-metallic character also increases. All right? The non-metallic character increases. So you need to know that summary, that nanometers, when you move across a period, the metallic character increases. Then down a group, the non-metallic character increases. So I think that is clear. So those are metals. So normally in the periodic table, 80% are metals. So metals, what are the features of metals? What are the characteristics of metals? They are solid, except mercury, which is a liquid at room temperature. So metals conduct electricity and heat. They are shiny, hard, and produce ringing sound when you strike on them. So during chemical reaction, metals can form positive ion by losing, I said that, and nonmetals, they gain by forming a negative ion. For example, sodium, when it gains to become sodium plus. So they are positively charged, and we call them cations, all right? So nanometals are around 22, and out of them, 10 of them are solid, 1 is liquid, and the remaining are gases, all right? So nanometals are elements which don't conduct electricity and heat. The only exception is graphite. You will see this in senior 3, why graphite can conduct electricity. So nanometals are brittle, they have dull appearance, and they are soft, non-strong, and shiny like the metals. So the metalloids, these are characteristics. There are elements, because for them they are found in the middle. They take sometimes the characteristics of metals and sometimes the characteristics of nonmetals, right? Depending on the element it has reacted with. So metalloids have got properties of both metals and nonmetals. Some of the metalloids, such as silicon and graphene, are semiconductors of electricity. So I think from what we have talked about here, we have tried to classify these elements of the periodic table in 3 classes: the metals, metalloids, and nonmetals, right? And we have tried to look at some of the properties of these metals and nonmetals and metalloids. So from there, you're going to try to do these questions that I put up there on the slide. You try to work out these questions. Most of them are from what, in fact, all of them are from what we have discussed. You remember we have talked about that the first question is, name the only nonmetal which is liquid, right? The nonmetal which is liquid, the only nonmetal that is liquid. You have talked about that. How many nonmetals are found in gaseous state? Remember we have talked about nonmetals being in a solid state, in a gaseous state, and only one being in a liquid state. So you name that one which is in liquid state, and you name those that we have said that are in gaseous state, all right? So the only nanometal which conducts electricity, the only nanometal that conducts electricity is graphite. Is it true? Have we mentioned that? Another question is, which is the most abundant nanometal in the Earth's crust? Is it carbon? Is it oxygen? Is it sulfur? Is it nitrogen? So nanometals are used to make a dash and dash. So what do you think nanometals are used for? So try to work out these 5 questions. They're all from what we have discussed here. And when we come back, we'll try to pass through the answers together here. So thank you so much for your good attention. Let's meet in the next lesson. Bye.